Hello everyone, myself Professor Nikita Ugale. So today we will see the topic isomorphism of graph. So first of all, what is isomorphism? So iso means same and morph means structure. So two graphs are isomorphic if they have same structure. So there are some conditions to check isomorphism of the graph. First condition is that the both graph must have same number of vertices. Second condition is that both graph must have same number of edges. Third condition is that we have to check the degree sequence. If the sequence of degree sequence of graph G1 and degree sequence of graph G2 must be same. After that, we need to check the adjacency preservation. Means the adjacency of vertices must be preserved under the mapping, and the last condition is that the vertex bijection. In that there must be exist one-to-one map, one-to-one and onto mapping between the vertex. So we will see first example. Question is here, determine whether following graphs are isomorphic or not. Two graphs are given, G and G dash. G and G dash, there are two graphs are given. So first we need to check the number of vertices in G and number of vertices in G dash. So we check here number of vertices in first graph, there are 5 vertex, 1, 2, 3, 4 and 5. Same in G dash, there are 5 vertex, 1, 2, 3, 4, 5. So first of all, write down number of vertices in G is equals to 5 equals to the number of vertices in G dash. Same for edges. So check the number of edges in G and G dash. So here total number of edges are 1, 2, 3, 4 and 5. In G dash 1, 2, 3, 4 and 5. So there are 5 edges. So I have written here number of edges in G equals to 5 equals to the number of edges in G dash. Next we need to check the degree of a vertices. Degree of each vertex. We need to find out the degree sequence of both the graphs. So for that, make a table for graph G and next for graph G dash. So graph G having 5 vertex, V1, V2, V3, V4 and V5. Then find out the degree of each vertex. So degree of each vertex, degree of V1, there are 2 adjacent edges to V1, therefore degree of V1 is 2. Degree of V2, here degree of V2, again there are 2 edges joined to vertex V2, therefore degree of V2 is 2. Next find out degree of V3, again here degree of V3 is 2, degree of V4 is 2 and degree of V5 is again 2. So write down degree of each vertex. Then next we need to find out the degree of adjacent vertices. So here degree of adjacent vertices. So adjacent to V1, for vertex V1 there are 2 vertex adjacent to V1, V3 and V4. So find out that V3 and V4 degree both having degree 2, therefore I have written 2, 2. Next we need to find out the degree of adjacent vertices of V2. Here for V2 there are 2 adjacent vertices, V4 and V5, both having degree 2, that is why I have written here 2, 2. Same for V3. So here for V3 2 adjacent vertices are there, V1 and V5, both having degree 2, that is why 2, 2. Next for check for V4. Again for V4 there are 2 adjacent vertex, V1 and V2, both having degree 2. So write here. Next check for V5. For V5 there are 2 adjacent vertex, V3 and V2 and V3, and both having degree 2. So write here. Same for graph G dash. For second graph we need to find out same vertex, their degree and degree of their adjacent vertices. Now write down the vertex of G dash. So there are 5 vertex V1 dash, V2 dash, V3 dash, V4 dash and V5 dash. So write down V1 dash, V2 dash, V3 dash, V4 dash and V5 dash. Find out the degree of each vertex. So degree of V1 dash is 1 and 2 edges are joined there. Therefore degree of V1 dash is 2. Same for V2, V3, V4 and V5. Find out degree and write down here. After that, degree of adjacent vertices. Same for V1 dash, there are 2 adjacent vertices, V2 dash and V5 dash. So find out their degree and write down here. So both having degree 2, so write here 2, 2. Next for V2 dash, there are 2 adjacent vertices, V1 dash and V3 dash, both having degree 2. So write here 2, 2. Next, check for V3 dash. Again for V3 dash, there are 2 adjacent vertices, V2 dash and V4 dash. So write down degree of V2 dash and V4 dash. So 2, 2. Next for V4 dash, there are 2 adjacent vertices, V3 dash and V5 dash, both having degree 2. So write down 2, 2. Next check for V5 dash. Again it having 2 adjacent vertices, V1 dash and V4 dash, both having degree 2. So write down here 2, 2. So after that we need to check the degree sequence of both the graphs. In graph G, the degree sequence is 2, 2, 2, 2, 2. And in graph G dash, again it have degree sequence 2, 5 times. So it having same degree sequence. So next we need to check that adjacency preservation. So degree sequence of both graph is same, therefore degree of adjacent, now we need to check the degree of adjacent vertices are identical or not. If they are identical, then we can say that adjacency of vertices is preserved. So for that check the degree of adjacent vertices. Here vertex having degree 2 having adjacent vertices 2, 2. Same in G dash, vertex of degree 2 having adjacent vertices 2, 2. Next again for V2, vertex of degree 2 having adjacent vertices 2, 2. Same in G dash, therefore there exists the adjacency of degree sequence. Here's 2, 2, 2. So we can map the vertex bijection. So here V1, we can map V1 to V1 because V1 dash, because V1 have degree 2 and adjacency is 2, 2. V1 dash having degree 2 and adjacency is also 2, 2. So we can map V1 to V1 dash. So f of V1 is equals to V1 dash. Now check for V2. V2 having degree 2, adjacency 2, 2. So we can map V2 dash, V2 to V2 dash. Therefore f of V2 equals to V2 dash. Again we can map V3 to V3 dash because its degree and degree of adjacent vertices is same. Same for V4 and V5. So we can map V4 to V4 dash and V5 to V5 dash. Therefore, we get all the properties of isomorphism. First one, number of vertices in G are equals to number of vertices in G dash, number of edges in G are equals to number of edges in G dash. Third one, degree of vertices, degree sequence is same as degree sequence of G dash. Then check the adjacency vertices, degree of adjacent vertices. So, here adjacency is also preserved. And the last one, vertex bijection. So, we get here vertex bijection also. Therefore, these both graphs are isomorphic. Now, we can find out the determine whether following graphs are isomorphic or not. There are two graphs are given, G1 and G2. So, first condition is that we have to check number of vertices in G1 and number of vertices in G2. Check here number of vertices in G1. So, how many vertices are there? 1, 2, 3, 4, 5 and 6. And number of vertices in G2, 1, 2, 3, 4, 5 and 6. So, it is equals to number of vertices in G2. Next, check the number of edges from both the graphs. So, number of edges in G1 equals to, so how many edges are there? 1, 2, 3, 4, 5, 6 and 7. So, 7. It is equals to, check the number of edges in G2. So, here 1, 2, 3, 4, 5, 6 and 7. Therefore, both graphs having same number of edges. Next, we need to check the degree sequence. Okay. So, for that, prepare a table for graph G1 and for graph G2. So, write down vertex of graph G1. Graph G1 having 6 vertices A, B, C, D, E and F. So, write down all the vertices here, then write down degree of each vertex. So, here vertex A having degree, there are 3 adjacent edges, therefore, vertex A having degree 3. So, write down here 3. Next, check for vertex B. Vertex B having degree 2. Vertex C having 2 adjacent edges, therefore, it having degree 2. Vertex D having 3 adjacent edges, that is why degree of D is 3. Next, find out the degree of E. So, E having 2 adjacent edges, that is why degree is 2, and for F again having 2 adjacent edges, therefore, degree is 2. Now, check the degree of adjacent vertices. Adjacent vertices of A, there are 3 adjacent vertex E, B and F. So, write down the degree of E, B and F. B having 2, 2, 2. So, write down here 2, 2, 2. Then for B, B having 2 adjacent vertex A and C. So, write down degree of A and degree of C. So, degree of A is 3 and degree of C is 2. So, write down 2, 3. Then find out for vertex C. C having 2 adjacent vertex B and D. So, B having degree 2, D having degree 3. So, write down here 2, 3. Then D. Vertex D having 3 adjacent vertex E, C and F having degrees 2, 2 and 2. So, write down here 2, 2, 2. Next, check for E. E having 2 adjacent vertex and both having degree 3. So, write down here 3 comma 3. Next for F, again F having 2 adjacent vertex and having degree 3. So, write down here 3 comma 3. We need to do same process for graph G2. Graph G2 having vertex P, Q, R, S, T, U. So, write down here vertex name P, Q, R, S, T, U. Write down their degree. So, P having degree 3. So, write down here Q having degree 3, R degree is 2, for S degree is 2, for T degree is 2, for U degree is 2. Okay. Then find out degree of adjacent vertices of each vertex. P having adjacent vertex Q, R and S. So, write down degree of Q, R and S 2, 3, 2, 2, 3. Then find out adjacent degree of Q. So, Q having 3 adjacent vertex having degree 2, 2, 3. So, write here 2, 2, 3. Next for R. R having 2 adjacent vertex having degree 2, 3. Next for S. S having, there are 2 adjacent vertex P and Q both having degree 3. So, write down here 3, 3. Next check for T, 2 and 3. So, write down here 2, 3. Then for U, 2 adjacent vertex having degree 2. So, 2, 2. Now, check here the degree sequence. So, degree sequence of G1 is, first write down it is in decreasing order. So, 3, 3, then 2, 2, 2, 2. And degree sequence of G2 is 3, 3, 2, 2, 2, 2. So, both having degree sequence is same. Then we have to check the degree of adjacent vertices also. So, check here in graph G1, vertex A having degree 3 having adjacency 2, 2, 2, but there does not exist a vertex having degree 3 having adjacency 2, 2, 2. Here there are 2 vertex of degree 3 having adjacency 2 to 3, no same adjacency. Therefore, these 2 graphs are not isomorphic. Okay. So, here full answer of that question same, we can see that here vertex having degree 3 adjacency 2, 2, 2. Here vertex having degree 3 does not exist vertex having degree 3 having adjacency 2 to 2. Therefore, both graphs are not isomorphic. Check here degree sequence written, then in graph G1 the vertex of degree 3 having adjacency 2, 2, 2, but there is no vertex in G2 having this adjacency. Therefore, degree of adjacent vertices are not identical in both graphs, hence the adjacency of vertices is not preserved. Therefore, G1 is not isomorphic to G2. Okay? Now, we solve the next example. Determine whether the following graphs are isomorphic or not. 2 graphs are given. First graph G1 having vertices A, B, C, D, E, F, H. So, write down all vertex all vertex of G1. Then write down degree of each vertex. So, in first graph, degree of A is, so there are 3 edges joined to A, therefore, degree of A is 3. So, write down degree of A is 3. Degree of B is 2. Degree of C is 3. Degree of D is 2. Degree of E is again 2 edges are joined to E, therefore, degree of E is 2. Degree of F is 3. Degree of G is 2. Degree of H is 3. Now, find out degree of adjacent vertices. So, A having 3 adjacent vertex, B, F and D. So, write down degree of B, F and D. So, B 2, 3 and B, F and D. 2, 2, 3. So, write down here 2, 2, 3. Then B. B having 2 adjacent vertex A and C. So, write down degree of A and C. So, 3, 3. Next C. 3 adjacent vertex 2, 2 and 3 degree. For D, adjacent vertex having degree 3, 3. For E, adjacent vertex having degree 3, 3. For F, the 3 adjacent vertex having degree 2, 2 and 3. For G, there are 2 adjacent having degree 3, 3. For H, 3 adjacent 2, 2 and 3. So, write down their degrees. Same do for the graph G2. So, graph G2 having 8 vertices, I, J, K, L, M, N, O, P. So, write down all the vertices, then write down degree of each vertex. So, I having degree 3, J 2, K 3, L 2, M 3, N 2, the vertex O having degree 3, vertex P having degree 2. Then find out degree of adjacent vertices. So, there are 3 vertex adjacent to I, L, J and M. So, write down degree 2, 2, 3. Adjacent to J, K and I both having degree 3, 3. K 3 adjacent 2, 2, 3. For L, 2 adjacent having degree 3, 3. For M, 3 adjacent vertex having degree 2, 2, 3. For N, 2 adjacent having degree 3, 3. For O, there are 3 adjacent having degree 2, 2, 3. So, write down here. Next, for P, there are 2 adjacent vertex having degree 3 and 3. So, first check here degree sequence. So, write down degree sequence of first graph G1. Write down in decreasing order. So, there are 1, 2, 3, 4 vertex having degree 3 and 4 vertex having degree 4. So, 3, 3, 3, 3, 2, 2, 2, 2. Check for graph G2. Again there are 4 vertex having degree 3 and 4 vertex having degree 2. So, both graphs having same degree sequence. Now, we need to check the degree of adjacent vertex. So, here we can map vertex A to I because it having degree 3 and adjacency is also same. Therefore, we can map here vertex A to vertex I. Then vertex B having degree 2 and adjacency 3, 3, it can exist in G2, therefore we can map here B to J. Next, vertex C map to vertex K. Vertex D map to vertex L. Next, vertex E can map to vertex 2 having 3, 3 adjacency, so we can map here E to N. Then vertex F 3 having adjacency 2 to 3, so we can map F to M. Then vertex G having degree 2 adjacency 3, 3, so we can map G to P. Then the last vertex H having degree 3 adjacency 2 to 3, it is same as the degree 3 and adjacency 2 to 3, therefore we can map H to O. Therefore here we get the vertex bijection also, therefore these two graphs are isomorphic. Here we have not checked the first condition for number of vertex and number of edges, so you can check here, it having same number of vertex and same number of edges. So here is the full proof of solution of these two graphs, number of vertices, number of edges. Next, check degree of vertex. After that, adjacency preservation. Here we get the degree sequence same. Degree of adjacent vertices are identical in both graphs. Therefore, adjacency of vertices is preserved here, and also we can define the bijection. Therefore, both graph is isomorphic. Okay. Next example is same. Determine whether following two graphs are isomorphic or not. So check here the first condition. Number of vertex and number of edges in both the graphs. So here number of vertices in G1, how many vertices are there? So total 8 vertex. In G2 also there are 8 vertex, so both are same, equals to number of vertices in G2. Next, check the number of edges. So here total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 edges are in G1. Check for G2. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So both having same number of edges. Then go for degree sequence. Prepare a table, first for graph G1 and second for graph G2. Write down the vertex of G1. So there are 8 vertex. Write down all A, B, C, D, E, F, G and H. Write down their degree and degree of adjacent vertices. Same for graph G2. There are 8 vertex P, Q, R, S, T, U, V, W. So write down all vertex here. Then write down their degree and degree of adjacent vertices. So for this example, degree of A is 3, degree of B is 2, degree of C is 3, degree of D is 2, degree of E is 3, F having degree 2, G having degree 3, H having degree 2. Write down its adjacent vertices also, degree of adjacent vertices. So 2, 2, 3 for B, 3, 3 for C, 2, 2, 3 for D 3 3, for E 2 2 3, for F 3 3, for G there are 3 adjacent 2 2 3 degree, for H 3 3. Then write down for graph G2, P having degree 3, Q having degree again 3, R 2, S 2, T 3, 2 2 and 3. So check the degree sequence. Here degree 3 having 4 vertex 1 2 3 4 and remaining 4 vertex having degree 2. So degree sequence is 3 3 3 3 2 2 2 2. For G2 1 2 3 4 vertex having degree 3 and 4 vertex having degree 2. Therefore degree sequence is same. Next check the adjacency preservation. So for degree for vertex P, adjacent vertices are S, Q and T having degree 2 3 3. For Q 2 3 3. For R for W it's 2 3 3. So check for the adjacency preservation. So we can check here, we can see directly here 3 having adjacency 2 2 3, but in G2 there does not exist a vertex of degree 3 having adjacency 2 2 3. So we cannot map the vertex, that is why these two graphs are not isomorphic. Here is a full solution of this question. Number of vertices having same, number of edges are same, degree sequence degree 3 having 2 2 adjacency, here degree 3 having 2 3 3. There does not exist a degree 3 having adjacency 2 2 3, that is why degree of adjacent vertices are not identical in both graph. Therefore adjacency of vertices is not preserved. Then G1 and G2 both graphs are not isomorphic. Now we see the last example. Determine whether following graphs are isomorphic or not. So again same process, same conditions are there. First check number of vertex and number of edges. In graph G1 there are 9 vertex and in graph G2 again there are 9 vertex. So vertex are in both the graphs are same. Check the number of edges. Number of edges are here 8 number of edges, again here 8 number of edges. Therefore both having same number of edges. Next check for the degree sequence and adjacency. So write down all vertex of graph G1 in first column. So U1, U2, U3 up to U9, and for G2 write down vertex of G2 V1 to V9. Then write down degree of each vertex. Next we need to write down the degree of their adjacent vertices. So we can solve this example. Write down degree of U1. For U1 only one adjacent vertex is there, therefore degree of U1 is 1. Degree of U2 is 2. Degree of U3 is 3, degree of U4 is 2, for U5 degree is 2, for U6 degree is 3, for U7 only one adjacent, therefore degree is 1, for U8 again only one adjacent is there, therefore degree is 1, and for U9 also degree 1. Check degree of their adjacent vertices. The adjacent of U1 is U2, degree of U2 is 2, so write down here 2. Then for U2 there are two adjacent U1 and U3, so write down degree of U1 and degree of U3. For U3 there are three adjacent vertices U2, U4 and U8, so write down their degrees. So 1, 2, 2. For U4 two adjacent vertices are there, so write down degree of U3 and U5, so 2, 3. For U5 degree of U4 and degree of U6, so 2 and 3. For U6 three adjacent having degree 1, 1, 2. For U7 U6 is adjacent and degree is 3. For U8 U3 is adjacent having degree 3. For U9 U6 is adjacent having degree 3. Write down the degrees and adjacent degrees of graph G2. So here degree of V1 is 1, degree of V2 is 3, degree of V3 is 1, V4 having degree 2, V5 having degree 2, V6 having degree 2, V7 having degree 3, V8 1 and V9 1. Then check the degree sequence. Degree sequence is same or not? In graph G1 there are 4 vertex of degree 1, write down it is in decreasing order, so 3 2 times, 2 3 times and 1 4 times. In graph G2 3 2 times, 2 3 times and 1 4 times, therefore degree sequence is same. Check for the adjacency. So for adjacency V1 having adjacent V2, degree is 3. For V2 V1, V4 and V3 are adjacent, so 1 1 2. For V3 only one is adjacent having degree 3. For V4 2, 3. For V5 2, 2. For V6 2 and 3. For V7 1 1 2. For V8 3. For V9 3. Okay. So check here the adjacency preserve or not. So we can check here one having degree 1 having adjacency 2, but it cannot exist in G2. It is not exist in G2. Here for 1 adjacency is 3, adjacency is 3. Here is also adjacency is 3, adjacency is 3. So for vertex for in graph G1 there is vertex having degree 1 having adjacency 2. It does not exist in graph G2. Therefore these two graphs are not isomorphic. Okay, thank you.